So continuing our topic on circles, we are going to look at chords. So what is a chord? Well, if you think about some other vocabulary maybe that you know, such as a diameter is a line that goes through the circle and through the center. Then we also have a radius, which is from the edge of a circle out to from the center of a circle out to the edge. And then we could also have what we looked at before. We have this central angle, which makes this arc around the side. Well, a chord connects two edges of a circle. But the difference is it's not a diameter because it doesn't go through the center of the circle. So this would be a chord. So a chord simply is a line through a circle, but not through the center. So this line goes right through the circle, connects two endpoints of the circle, but does not go through the center. That is a chord. So first theorem we're going to look at is that in a circle, if a diameter or radius, because radius is just half a diameter, if that line is perpendicular to a chord, then the chord is bisected, and so is the arc. So here we have a nice radius. This is the radius. And we can see that this chord, let me get back to my straight line tool here, and we have this chord which doesn't go through the center of the circle, making it a chord. Because it is perpendicular to the radius, that means that the chord is bisected, so x is equal to 13. That is a key problem, and it will help us with stuff like this. So here, number one, nice simple problem. I see a chord, I see a diameter. They are perpendicular, so that means that the chord is bisected, so x is equal to 18. Now over here, we have this line here, which is a radius, and we can see that this is our chord. Well, what we could do is we could say this chord, if this is 8.3, this is also 8.3. This radius is 21, so this is 10.5. So we have x squared plus 8.3 squared is equal to 10.5 squared. We could also set this up so that we could say, hey, the radius is 10.5. So that means that this distance is 10.5. So x plus 4 is equal to 10.5. So x is equal to 6.5. Either way works. They're both acceptable ways. Right, so here we can see that the diameter is x, so the diameter is x digits long. This is the chord, so that's 15, meaning that this is 15. And so 2 times x, so this is x over 2. So we could say that 10.1 squared plus 15 squared equals x over 2 squared. Or, yet again, we can see that this is the radius, and so that radius is 10.1 plus 8, which is equal to x over 2. So that means that 18.1 equals x over 2. So x is equal to 36.2. Either way, get you that answer. And then over here, we have yet again a similar setup. So I'm not even going to use Pythagorean theorem on this one. I'm going to say, all right, so this is the diameter. So that means that the radius is half of it, which is 13.2. And here this is also a radius. So we have 13.2 is equal to 4.5 plus x. So we get that x is equal to 8.7. So a little bit of work, a little bit of thinking. The setup might take you longer than it took me here, but that's okay as long as you think logically about the pieces of the circle and what equations to set up. All right, now we have another theorem that says if you have two congruent circles, two chords are congruent, or sorry, in one circle or two congruent circles, you are going to have congruent chords if they're equidistant from the center. So here I have two chords in one circle. I measured their distance by finding a line that's perpendicular. So these intersect at 90-degree angles. Those two chords are equidistant. That means that the overall distance is going to be, or the overall length of the chords is going to be equal. So let's look at some examples here. So we have this circle H with the measure of the arc is 82, so RS. So this whole arc is 82. Our distance of this segment RS, so this chord, is 46, and TU is equal to RS. Well, because TU is equal to RS, there you go. Those are two chords. They are the congruent, so that means that MH must equal, means that MH must be congruent to HK, or K, HK, KH, doesn't matter. Because that's the theorem we just looked at, if two chords are congruent if they're equidistant from the center. So let's find some lengths. So TU. Well, we know that RS is 46, but look, it's perpendicular to this diameter, to this radius. So that means that it's bisected. So that's 23, that's 23. And because we know that it's congruent, RS is congruent to TU, these subsegments are also congruent. So TU is equal to 23, as is TK. MS is going to be that same distance. And then for HKU, so HKU, notice because the chords are congruent, means that they're the same distance apart from each other, meaning that this is also 90 degrees. So HKU is going to be equal to 90 degrees. The measure of the arc AS, well, if the measure of the arc RS is 82, don't forget our theorem that says we can bisect the chord also says we can bisect the arc. So this is 41, and that's 41. So measure of this is 41. The measure of AR is also 41. And then for TD and DU, 41, 41, notice those are the same arcs, those are the same chords, so they are going to be the same measurements as well. So here, a little bit of thought processing. Know your theorems, know the definitions of the parts of this circle, and handling problems like this becomes so much easier. So get some practice.